Today we are going to talk about covalent compound molecules and we will see some examples of them. Okay, so let's continue. What is a covalent molecule? A covalent molecule is formed by when elements share electrons. So a covalent bond is a type of chemical bond that involves the sharing of electron pair between them. And when molecules are formed by covalent bonds, like by sharing of electron, then it overall is known as a covalent molecule. Example, water. Water is an example of covalent molecule. This is not ionic molecule. Okay, unlike ionic molecule or NaCl, MgO, and the others which we just saw or recapped, in those molecules we were seeing that one element is giving electron and the other one is taking electron. But here it doesn't happen like this. Here what happens? Oxygen shares one electron with each of these hydrogen. Okay, so oxygen share one electron with this hydrogen and one electron with the other hydrogen. Okay, let me explain you the concept of sharing, see, or the rule of sharing. With the same example, oxygen has 6 electrons in its outermost cell. Hence it is deficient by 2 electrons to complete its octet. Means it is looking for 2 electrons. Somehow it is trying that it can get 2 electrons. Okay. Similarly, hydrogen atom has 1 electron in its outermost cell. Okay. This another hydrogen also has 1 electron in the outermost cell. Hydrogen had the option of completely donating the electron to oxygen. This option was also there, but mostly this is not what happens when a bond is formed between oxygen and hydrogen for some reason, because both are non-metals. Complete transfer of electron is not a favorable case in this case. So here, what happens? This hydrogen and this oxygen, they come close to each other and they start sharing a pair of electrons. The rule of sharing is that since rule of sharing in atom is hydrogen is sharing one and oxygen is sharing one. So rule of sharing is now these two electrons, one coming from oxygen and the other one coming from hydrogen, can be treated as a common electron. Means hydrogen can also say that these are my electron and even oxygen can say that these are my electron. Am I clear?
Yes, sir.
Yes.
Okay, same thing about this pair of electron. Therefore, we represent it like this. Like this is oxygen. These are 4 personal electrons of oxygen, which it is not sharing. Okay, it shares one with hydrogen to form a bond. So I can show that electron here, and this is hydrogen. Okay, I can show hydrogen electron with a cross also if you want. Okay, and this is another hydrogen. Okay, this is the first hydrogen, and another hydrogen also sharing one electron. So, again, the rule of sharing is that every atom gives one. So this one electron is given by oxygen and the other one by hydrogen. So this way, a bond is formed between hydrogen and oxygen, and such bonds are called as covalent bond. Okay. Now, this pair of electron, one came from hydrogen, one came from oxygen. That pair of electron is called as shared pair of electron. Okay, so please remember the pair of electron which is shared, one coming from each atom, like oxygen gave one and hydrogen gave one. So that one pair which is forming the chemical bond is known as shared pair of electron. Okay, you will also observe that oxygen had few other electron which it is not sharing. Okay, this electron, for example, this pair of electron, these are personal electrons of oxygen. And even this pair, so these two pair which are not getting shared with anyone are called as lone pair. Okay, I'll write it in full. Lone pair of electron. Okay, so a covalent bond is a type of chemical bond that involves sharing of electron pairs between its atom. So this bond is formed by sharing of electron. Share the electrons which are getting shared one by each atom is known as shared pair of electron. Okay, so one shared pair of electron is used for making one covalent bond. Okay, another shared pair for another covalent bond. Every shared pair makes one covalent bond. While you will also find sometime that some element have some valence electron which are not used for sharing. Okay, so they just stay as personal electron of oxygen or some other element. So they are lone pair of electron. Am I clear?
Yes.
Okay, let's say a bond between hydrogen and chlorine. Okay, what is the electronic configuration for chlorine? 287 means it has 7 valence electron, correct? Let's draw it here like this. And one more. How hydrogen has how many electrons? I think just one.
One.
Now they share these electrons. Hydrogen share one electron with one chlorine. And this way they form a bond. Does hydrogen have any extra electron after formation of bond? No.
No, sir.
But chlorine has 6 personal electron, which it is not sharing, like from the outermost cell. Okay, so they become 3 pairs. So I can say chlorine has three lone pairs. Okay, and this one here is bond pair. Simple. Can I move forward?
Yes, sir. Yes, sir.
Okay. Now, covalent bonds can be of different categories. So it can be a single covalent bond, it can be a double covalent bond, and it can be a triple bond. Okay. Look at this molecule here. Can you see a hydrogen?
Yes.
It
Yes.
is a H2 molecule. And we know in hydrogen what happens is each hydrogen had one electron and they're sharing that one electron. Correct. So each of these hydrogen are sharing that one electron to form one bond. Hence the bond is called as like single covalent bond. Okay. So here this both these hydrogens are like just sharing one electron. So when two elements just share one electron, it is known as single covalent bond. We have an example of like next double covalent bond. When two pair of electrons are shared between two atoms, it forms a double covalent bond. For example, okay, here we have oxygen molecule. So we know clearly that in oxygen has six valence electron, right? So oxygen has six valence electron, and even this oxygen had six valence electron. They needed two more. Okay, so how to get two more? Okay, so what they can do is they can start sharing two electron. So they can both share one electron here, one pair. Okay, so this is one pair and this is another pair. So among themselves only they share two pair. Clear? So this way they form a double covalent bond. Is this fine?
Yes, sir. Yes. Yes, sir.
Next, sometimes you will also see that two elements they start sharing three electrons between them. Okay, this can be seen in case of nitrogen molecule. Okay, so in case of nitrogen molecule, we see that both these nitrogen are sharing three electrons. Nitrogen has five electrons in the valence shell. So if it shares three, it will get a benefit of three. Means how much ever you share, no, that much only advantage you get. So if it shares three out of five, okay, it will get an advantage of three more. So 5 plus 3, it will become 8. And the two electron which it does not share are known as lone pair of nitrogen. Okay, so just for nitrogen, I can say this is one lone pair and it is sharing three to form three bond pairs. Clear?
Yes, sir. Yes.
Okay, so triple covalent bond means that the same element is like same two element is forming three bonds. Okay, see one example is nitrogen forming three bonds with hydrogen. This molecule is called as ammonia. NH3 is ammonia. So sometime in a hurry we say nitrogen is making three bonds, so it's a triple covalent bond. But this is not a triple covalent bond because nitrogen is not forming three bond with the same element. It is known as triple covalent bond when it shares the three electron with the same element. Okay. Then what do we call such a case like this case? This is three single covalent bond. Like this is a covalent bond, this is another covalent bond, and this is another covalent. So this is a case where a molecule has three single covalent bond and not a triple covalent bond. Am I clear?
Yes, sir.
I hope no
Yes.
problem. Let's see formation of hydrogen molecule. Okay, I'm just going to brief through this. So hydrogen molecule, what's formula for H2 molecule? Sorry, hydrogen molecule.
H2.
Yes, sorry. H2 is the molecule, right?
H2.
Formation of hydrogen molecule means yes. So H2 is formula for hydrogen molecule. Hydrogen atom only has one electron in its outermost shell. In order to attain the stable nearest noble gas configuration, which is nothing but the duplet of helium, the two hydrogen atom mutually shares one electron each and forms a covalent bond. So here, one more hydrogen comes in. This also has one electron. Both these hydrogen desires to get two electron. So they start sharing electron and become a hydrogen molecule. So one hydrogen has a white color electron and the other hydrogen has a red color electron. The color coding is just to help you understand that these are two different electrons coming from two different hydrogen and they combine together to form a hydrogen molecule. As only one pair of electron is shared between the two hydrogen atom, it is referred as a single covalent bond. Okay, so in the electron dot diagram, we just take hydrogen with a valence one electron and the other hydrogen with a valence one electron. They combine and then you put the shared electron right in between them. Okay, this is the electron dot diagram. This is electron dot diagram. but we can also write it with a bond line formula, where for every bond you just draw a line. And in the condensed form, the molecule can be written as H2. One pair of electrons that is shared between them, and hence it is a single covalent bond. Further, chlorine molecule, Cl2. Chlorine atom has atomic number 17 and the electron configuration is 287. And it has 7 electrons in its outermost cell, right? So because the electronic configuration is 2 at 7, there's 7 electron in the outermost cell. First cell has 2 electron, the second cell has 8 electron, and the third cell has only 7 electrons. 7 means this chlorine is not happy or satisfied. It is looking to achieve an electronic configuration of with a 8 valence electron. Okay. So in order to attain the stable electronic configuration of the noble gas, which is the next noble gas after chlorine? Chlorine is atomic number 17. After chlorine, the next noble gas is atomic number 18, argon. Okay, argon. Argon has 8 electron in the valence shell. So chlorine also is thinking that somehow I can get that one more electron so that I can become stable. Okay, so therefore two chlorine atom mutually shares one electron. So we get two chlorine atom. So both have 7 electron and they are looking to collide with each other and form a bond. Okay, so these two chlorine atom combine and they form a chlorine molecule. Okay, so now they have combined by sharing that single electron. Okay, in this chlorine molecule, can you tell each chlorine atom has how many lone pairs of electron? How many lone pairs are there in each chlorine atom?
In each three. Three.
In each is 3. Okay, so you must be able to understand and answer such questions. They can trick you with these questions. Each chlorine atom has 3 lone pair of electron because chlorine had 7 electron. It shared one to get 8. So it has formed a bond pair, and there are 3 lone pair which is not getting shared. Okay. And therefore, what is nature of the bond between the two chlorine atom? Is it single covalent or double covalent or triple covalent?
Single.
It's just a single covalent bond because only one pair of electron is getting shared. Okay, so it's a single covalent bond. Simple.
Yes.
Only one pair of electron is shared between the two chlorine atom. It is referred as a single covalent bond. Okay, yeah. So even here the diagram is represented two chlorine forming a single bond. Draw two chlorine with a lone pair of electron with 7 electrons around it and share one of them. So the shared electron, as you see here, comes right in the center. Like this is the shared electron. Correct? So they share one electron to form a Cl2 molecule. There's one more way you draw the electron dot diagram. Okay, I'll show you that as well. Okay, so we draw one chlorine and then overlap it with another chlorine. The shared electron you keep in middle. So there's 2 coming from each chlorine. And the unshared electron you keep in their personal space. So the unshared goes in the personal space and the shared goes in the common space.
Yes, sir. Yes, sir. Yes, sir.
Let's move ahead. What is formula for
O2.
oxygen molecule?
O2.
O2. So it consists of 2 oxygen atoms. What is atomic number for oxygen? 8. The electronic configuration is
2, 6.
2, 6. So how many valence electrons are there?
6.
6 valence electron. Okay. The 6 valence electron means outermost electron. Okay. Therefore, valency of oxygen is
2 plus. Sorry, 2. Yeah.
2 minus.
2 minus.
And in this case, also oxygen is just sharing electron. Therefore, putting a plus and minus sign is not compulsory. In covalent molecules, elements are not giving or taking; they're just sharing electron. So here you can see an oxygen. It has 6 electron in the valence shell. So it needs more electron in the valence shell so that it can get a stable electronic configuration. Okay, so it finds another oxygen atom which has the same electronic configuration. The color coding is just to differentiate between the two. They combine, and as we know that they are going to share 2 electrons now, not 1 electron. Okay, so can you see in between them they have shared 4 electrons. Each are contributing 2. Okay, so in between, if you see, there are 4 electrons, 2 coming from each oxygen. Okay, so in order to attain the stable nearest noble gas configuration, that is octet of neon, the 2 oxygen atom mutually shares 2 electron with each other and forms a covalent bond. As 2 pairs of electron are getting shared between the 2 oxygen atom, it is referred as a double covalent bond. So this is how the double bond look like with the 2 bond lines. Okay, electron dot structures are like this. 2 oxygen atom, they're sharing 2 electrons, so they form a double bond and the molecule is O2. All right, you can just remember that. So here 2 oxygens are there. You can just write the 2 shared pair in between. 2 oxygen atom, 2 oxygen atom, So 2 plus 2 4, and then the unshared pair you can write here. So in this case, we see that each oxygen has two unshared pair. Unshared pair is called as lone pair. Remember the word lone pair, and it has two shared pair between them, which are responsible for the formation of double bond. All right.
Yes, sir.
Let's nitrogen atom has an atomic number of 7 and electronic configuration of 2, 5, and has 5 electron in its outermost cell. Okay, so we can see that in the diagram as well. It has 2 and 5 electrons. Okay, now it comes in contact with another nitrogen atom, which also has 5 electron in the valence shell. So both are trying to get 3 more electrons, right? Because only by getting 3 more electrons they can be more stable. Okay, so by getting 3 more electrons, they are trying to achieve electronic configuration of the nearest noble gas, which is neon. Let's see how the sharing happens. Okay, so now you see here in nitrogen, between them there's 6 electrons getting shared, 3 coming from each nitrogen, correct?
Yes.
Yeah.
As 3 pairs of electron is shared between the two nitrogen atom, it is referred as a triple covalent bond. Okay, this is how the triple bond looks like, and this is how the electron dot structure looks like. Okay, so the next topic we have is polar covalent compounds. See, all the compounds which we saw till now are non-polar covalent compound. All the 3 examples which we saw till now were all non-polar covalent compounds, whether it is hydrogen or oxygen or chlorine or nitrogen. These are non-polar covalent compounds. Okay, so let's see what is a polar covalent compound. Okay, let me explain you with an example. So can anyone describe what is electronegativity?
Tendency to attract
When
electrons.
an element attracts electrons to itself,
To attract.
Which electrons?
from another atom.
Electronegativity is a tendency to attract which electron? The shared pair of electron. Suppose here A and B are forming covalent bond. So if they are forming covalent bond, they need to share electron, correct? Okay. My general logic says that since both are sharing electron, the shared pair of electron will remain right in the center of the two element. That is what my common logic is trying to suggest me. That since both are sharing the electron, the shared electron would stay where? Right in the center of the two atom.
Yes.
But this is not always the case. In fact, most of the time when two different element combines to form a covalent bond, one of the two element is more electronegative than the other. Okay, one is more electronegative than the other, because of which that electronegative element tries to pull the shared pair of electron closer to itself. Okay, and this tendency of a body of an element to do so in a chemical bond is known as electronegativity. So because B is trying to pull the shared pair of electron, this shared pair of electron, closer to itself, and it's not keeping it in the center. Okay, so instead of keeping it in the center, B is trying to pull the shared pair of electron more closer to itself. We can say that B is an electronegative element. Okay, that whenever a chemical bond is formed between two elements such that one has higher electronegativity, like one has higher electronegativity and the other one has lower electronegativity, means one is more electronegative than the other, then in such case, the shared electron won't stay in the center. It will get drifted towards the element which has more electronegativity. Am I clear?
Yes, sir.
That makes sense? Okay. Now, see, if I look at these two bonds, like sodium chloride bond between sodium and chlorine, this belong to the electrovalent category or the ionic category. In ionic category, there is complete transfer of electron from sodium to chlorine. Therefore, sodium has a plus charge and chlorine has a minus charge. Then we also came across bonds between two hydrogen atoms. In this case, they're just sharing electron and okay, so they're just sharing electron and the shared electron are right in the center. It's right in the center. How I am saying so? Because both these hydrogens are equally strong. I cannot say that this hydrogen is stronger than the other because they are the same element. So until two elements are different, we can never say that which one is stronger, which one is weaker. In fact, whenever the two elements are same, we will also always, without dispute, believe that both elements have the same strength, same electronegativity, and therefore none of them would be able to pull electron closer to them. So those two electrons would be right in the center. Okay, such molecules are called as non-polar molecule. Clear? Okay, what about a HCl molecule? See, in case of HCl molecule, see this chlorine has 7 electron and hydrogen has 1. So they're sharing 1. So one comes from chlorine and one comes from hydrogen. Now in this HCl molecule, the shared electrons are not in the center. Am I clear? That we know, right? It's not in the center. It is not in the center because chlorine is more electronegative than hydrogen, and therefore the shared electron drifts towards chlorine. Okay, so these electrons, I think better we can drift it a little bit more. So this is where the shared electrons are. Now, see, chlorine is not taking hydrogen electron. We can't say that because taking means taking it completely. But if it is not keeping in middle, right in the center, isn't it like partial taking only? Can I say it's like partially taking, not completely?
Yes, sir.
Does that make sense to you? Okay, so in this case, what happens? Since chlorine has partially taken the electrons are not in the center. It is slightly drifted towards chlorine. Therefore, chlorine gets a delta negative charge. You'll say, what is delta, sir? Delta is a fraction whose value is less than 1. Okay. Similarly, hydrogen gets a delta positive charge. What is delta here? Again, a fraction whose value is more than 1. Sorry, less than 1. A fraction whose value is less than 1. Means, sir, we are trying to say that chlorine and hydrogen has partial positive and partial negative charge. Am I clear? Okay. And such molecules where one side is partially positive and the other side is partially negative is known as polar molecule. I hope that's fine.
Yes, sir.
Yes, sir.
So a molecule in which one side is slightly positive and the other side is slightly negative is called as polar molecule. Polar covalent bond only depends on the electronegativity difference and polar bonds. Not entirely. Let's suppose I'll give you 2 examples. So again, let's take hydrogen chloride. See, if we look at this overall molecule, okay, suppose this is the overall molecule. Hydrogen side is slightly positive and chlorine side is slightly negative. Therefore, this is a polar molecule. Okay, it is a polar molecule because the shared pair of electrons are closer to chlorine. See how technical it is. Chlorine has more electronegativity. Hence, the shared pair of electrons is closer to chlorine. Therefore, chlorine gets a partial negative charge and hydrogen gets a partial positive charge. And the overall molecule becomes positive from the hydrogen side and negative from the chlorine side. And hence, it's known as a polar molecule. Make sense? Because now it has poles, right? One side is positive and the other side is negative. Okay, so see again, HCl molecule. I said HCl is a polar molecule. Polar molecule because see hydrogen side is positive and chlorine side is negative. And this bond between hydrogen and chlorine is a polar bond. Okay, so it's a polar bond because the electron pairs are drifted towards chlorine. Okay, let's take another example. Carbon tetrachloride. Okay, a question which comes very often in Icse exam. Okay. Now in carbon tetrachloride also, this is carbon tetrachloride. It means 4 chlorines are sharing one electron with carbon. Okay, so even in this case, the shared pair of electrons are closer to chlorine, isn't it? Okay, so this shared pair of electrons are not middle. Where it is? It is closer to chlorine. That means each of these chlorines are negative charged, slightly negative, not completely negative, because they are. If they completely take the electron, then it is +1, -1. But here they are slightly pulling towards itself, so it is delta negative. And what about carbon? Carbon is slightly positive charge because it is giving little electron to each of these chlorines. Okay. Now mostly students think this carbon and chlorine has electronegativity difference and chlorine has negative charge. Therefore, this molecule is also polar molecule. Okay. Now my question to you is, can I say this is a polar molecule?
Mm, One side there's negative and positive, so yes, it is a polar molecule.
Yes.
Nishika says
But
yes. Koshi, what is your opinion on this? Do you think
it is yes.
is this a polar molecule?
Yes, it is.
Yes.
Yeah.
Please understand one thing. If you ask me, sir, is these 4 bonds polar in nature? Yes, they are polar in nature because chlorine has a slight negative charge and carbon has a positive charge. But is this overall molecule polar molecule? No, the overall molecule is not polar. It's a non-polar molecule. Why is it so? It is because if you look at the structure, positive is not on one side, it is in the center. Okay, positive is in the center and from all the sides it's negative. So when the overall molecule is negative from all the corners and positive in the center, then it's not polar. Polar means that one side it is positive and the other side it's negative. Okay, so when there are more than one bonds, polar bonds in the structure, okay, in the molecule, if there are more than one bonds, polar bonds, then you need to look at their orientation. Are they in opposite direction that they are canceling out each other, or are they in the same direction? Okay, makes sense, sir. So polarity cannot be just decided on the basis of electronegativity, but we also need to know the structure of the molecule. So see, briefly what I just said is, like, if in a molecule, suppose this is A and it is connected with 2B. Okay, B is electronegative. This is also negative, and this is positive. Okay, then overall molecule, if you see, it is positive in the center and negative at corners. So this is not polar because they're in opposite direction. The the two bonds are in opposite direction, so they are canceling out each other. So this is non-polar. But suppose the structure is like this. Okay, for the same AB, if suppose the structure is like this, A and then 2B like this, not straight, then these are negative, negative, and positive. Now, if you look at the overall molecule, this side is negative, this side is positive. So it is polar in nature. So if there are more than one bonds, you need to see how the bonds are arranged. Are they opposite to each other? If they're opposite to each other, then they will cancel out their effect. Okay. If they are aligned at some angle, then they won't cancel out each other. Then still one side will be positive, one side will be negative. Then the next question comes are, how do we know the structure? Okay. Good news is you don't need to know structure because that's not in your syllabus. That comes in 11th grade. Then what do we do with our current situation? Current situation, you just need to know about 4 molecules. Learn in those 4 molecules which is straight, which is bent, which is okay. So only focus on the structures which we are going to discuss. Okay, so another 4 or 5 structures are there. So just in this case, it is polar or non-polar. Like for example, carbon tetrachloride. I said the bonds are opposite; they're canceling. So remember this structure. That's it. Okay. So so we will see structures of non-polar molecules, more of them in the next class. Okay. So I think for now it's enough. We'll meet again on Wednesday. Okay, I think that's fine then for today. See you later. Thank you and bye.